Hello YouTube, this is Ready Set Exploit and we're gonna be doing Advent of Cyber 2023, the side quest for the Bandit server, which is a challenge I created that highlights a couple of vulnerabilities. It combines SQL injection with a server-side request forgery so that we can get the pin of a Werkzeug server. So it starts with a web server that claims to have this new way of downloading images, and we see that it is running Flash Werkzeug. So that's where the SQL injection and server-side request forgery come in handy, so that we can view the files on the server, which allows us to get the pin. With the pin, we can get access to the Werkzeug console, which happens to be on, and we could execute code. With that, we get access to the server, and then poking around, we see that it's using Git as a version control software. Going through the commits, we find a password for the current user that was previously used, and we can run a bash script as root. And the script at first seems innocent, like there's no vulnerabilities on it, but we actually find a very, for lack of a better word, sneaky path injection using a bash built in. So I'll go into that in a bit more detail. So without further ado, I'll get started. So first thing is, let us get our everything set up. So I have a window open, call this Nmap, and I'm gonna do sudo Nmap min rate 10,000 10.167.30-p dash, and it's gonna go ahead and enter our password, and right away we have port 22, and it takes a second and it should find another port relatively fast, port 8000. So I always do this kind of scan because it is pretty fast. And then we dash vz-on so dash vc runs version scanning, and runs dash c runs our dash sc runs our default scripts. It saves it to a file called nmap.txt. We save it to this IP address that we had, and then we do port 2022 and then port 8000. Now this scan can take a little bit of time because Nmap for some reason does take some extra time when examining Werkzeug. So now we can't really do much with SSH. We don't have any usernames. We don't have without usernames we can't really do any password spraying. So brute forcing any kind of attack is out of the question. So while we wait for Nmap scan, let's check out database. And we have this web page, the BFG, small nod to the Doom game. If you've played it, it stands for the best festival company, but the Doom game stands for the big effing gun. So I think it actually stands for something else, but that's what most people call it. So we have this site that says a new and innovative way to download images. Click on any elf to try it out, and we have this beta version 1.01. You can see on the bottom left we have a query going to download with a parameter of ID equals 1, 2, and 3. We can inspect the source, see if there's anything. And so very interesting here. We have a link and then the image location. Right? And this is the image here. We can eliminate the view source, and we have the image. So that's very interesting. We have two kinds of queries. That's very odd. Still scanning. So let's just click on one of them, and we have image here. Now, so it just downloads the images. So typically on most servers, you would just find a link and then it references the image, but that's pretty much how it should. So this is interesting. It would have a link also pointing to the image, so that's kind of odd. Let's see where it takes us. So if we do download like we saw, ID equals, you can go through all of them. Let's see, let's do never. We get a type error. Did I delete this file? Oh, so our scan. So we'll go back to that error there. But for now, let's focus on this. So it takes some time because it looks like Nmap can't fully parse Werkzeug. So it takes a little bit extra time. But as we saw, this is SSH. It gives us the distro information, which can be helpful. Ubuntu. 48000 is our web server. Werkzeug, which is just a framework, a web framework run in Python, Flask. We had the title already, and then it just doesn't give us much after that. So does give us some basic info, but this is pretty much it. So we can go back. This error here, if you did your basic Go Buster, you would have run into this console here. This usually can be turned on, can be turned off. It's turned off by default, I believe. This allows you to debug the code. Now, if we Google that, what is Werkzeug debugger or debug console? And you see there's a lot of ways to get remote code execution. The official documentation does say that the debugger allows the execution of arbitrary code, which is security risk. And actually, there's a big news. I think is Patreon hack 2015. That is how Patreon got hacked. Except there was one key difference. There was no pin for Patreon. If we look at Werkzeug PIN exploit, it's not really an exploit, but what we have this page from Hacktricks, so you can run this code here using a command like this, right? Import the OS, and then pop open who am I. And the interesting thing is we're able to get the pin. We just need the public bits, private bits, and we're able to get these some of these files here, which I'll go over, and this is what the whole exploit will look like. 2 different hashes depending on the version. This will give us our pin, but all in due time. If we go back, this is an error that we have because of this. So the view function will now return a valid response. It's either none or ended with a return statement. So it kind of exposes. First thing we notice is where the code is located. So we have a username here, right? Home Skitty, so that's good to know. Let's see. There's a response. So we have a potential username. Can we brute force? I wouldn't try it just yet. But we do have this here. You can execute printing the stack frames. This kind of jumps out. If we Google that, kind of run through, there's a couple of mentions of, let's see, doesn't jump out right away. What is that? Bugger. Let's see. Okay, I thought it would jump right out. Maybe if I just Google that. Let's see, what is that? When I run, there we go. I was looking for this one. So there's kind of a hint of SQL. So it's possible that it is using, see, we get similar error here. There you go. It's possible that it is using some kind of SQL, but we can test this out. So if we do maybe something like a single quote, we get a type error. I mean a double quote, but what if we do a single quote? Error is different. MySQL, so now we have the database software that is using, and we have an error in your SQL syntax. And again, that's what's odd about this site that's claiming to do it in a new way. So if we're dealing with an SQL error, possible SQL injection, we are, it's definitely loading the images from the database, possibly, and then showing it on the site. Most servers just statically plays the images on the server, and the link just refers you to where the image is. So kind of an extra step, but that's the point of this challenge in a way, to kind of take advantage of when someone tries to think of a new way. Sometimes it's not necessarily the greatest way, and up to us to figure out why not and what could go wrong if you don't properly patch some things, but more into that in a bit. So we have an SQL injection, right? And typically I don't like to run sqlmap, but especially because sqlmap, last time I checked, is not allowed in exams like the OSCP, for example. So I don't like to run it, but for the sake of this exercise, I'm going to run it here. I'm actually going to close that. And just so that you can see, running sqlmap, typically I would do it manually and then write up a Python script, but don't want to waste your time doing that. So what I'm going to do is I'm going to run it, sqlmap. I think it's -u, and that's the URL. Probably should have do this, and we need the parameter, which is ID, and I'm gonna do I want to dump the databases. I want to do batch. This is so I can just agree to everything without pressing yes. I believe that's it, and it's gonna do its thing. And there it is. So it does find my injectable, MySQL. So this is all part of web fundamentals. When you see an ID parameter, any kind of parameter, you want to kind of throw things at it to see what kind of response we get. And so far, we're able to tell that it is a possible SQL injection, and it's running the debugger. So let's see what else we can do. It's going to take some time at first, and then it's going to go really, really fast. Let's see, and there we go. We have a payload and fetching databases names, and we have database right here. Information schema, performance schema. That's interesting. So it's definitely loading from there, which again, it's odd, but let's figure it out. Elf images. Now I want to dump tables. That's gonna go much faster now. Elves -t elves, and we do dump, and we have ID, URL ID, URL. You're probably gonna get these errors due to some libcurl. So we know another thing it tells us is just some kind of libcurl, and there we go. So those are the entries, so it goes by the entry ID. But here it is, URL ID, URL. So this is where the images are stored, which we saw earlier. This was the first Easter egg. There is a fourth image, and it takes a second to download. And these are the suspects. So this was just a little Easter egg that I would throw in there if anybody was curious enough to download it. But going back, we have these for images. So what it's probably doing something like select from elves. No, select URL from elves where URL ID equals, and this is where the comma, and then this is the query, right? So when we inject here, and that's what creates the error. So now let's go ahead and turn, gonna use burp, and let's see what we can do. And a good payload that I always like to do is the injection. So this kind of gives you an idea. So the next thing to try here is, can we control this? Can we inject it, use some kind of union injection, because the image is being displayed to me. So which means it's probably looking at it either as a URL or a file or both. So that's what we have to find out. And if we can inject it, so we could probably do something like so let's see, like, I don't know, something here. Actually, we don't have to do anything. We do, so our query would be there. We'll end it there. Union select, and because only the image is being displayed, we know only one column is being used. But you can always brute force it by going 1, do 1, 2, 3, and so on. But in this case, it's just 1 because only one is doing it. And we can also show that. And then we're gonna get the one column, right? So we ended the query here, and then we do and union select, then we're going to comment everything else out. We're going to comment this single quote, and that's pretty much, that's our whole payload. So first thing is first, I'm going to go here. There we go. Capture that request. Turn this off. I didn't mean to do that. It's gonna confuse me. There we go. And see, we have here, and we do downloads. Download RD equals 1, and we send it. And we can't render it, but we could see that there's some image files here. So there it is. So if we do a single quote, we see the error there. So let's inject our payload. So another way is to do something like this. You see, it still works. So let's go for it. So I'm not gonna put anything. I'm gonna do union select. Now I'm gonna do 1. And we probably won't get a response because it has nothing to load. See, nothing's coming up. That's okay. Now we can inject, right? So if I do 2, see, the use select statements have a different number of columns. That means our columns are not right. So can we control what? So it looks like it is, since it's loading, select URL. Let's see if we can send it to something we can control. Call this server. There we go. And because it's loading the URL and we inject the URL, it will load here. It will load whatever it's pointing at, right? So this query now becomes select from URL where URL ID equals union select that we're going to point to union select our URL. So it's going to load from there. So let's see. Didn't mean that. And we got a response. See, get from our target. So this, see, there's our file. This means we have some sort of server-side request forgery. And this allows us to interact with the server, probably locally. And there's a lot of payloads. Let's see, the most common is, can we read files, right? The file protocol, it's a way to read files, works as a URL. So let's try it. If we can read files, then going back to the PIN exploit, it means we can get the PIN. And there it is, we can read files, there's our user. We could probably read the source code, right? Home, Mac, Skitty. Let's see, if we don't know where the code is, there's a couple ways to find it. We do prof self cmd line. I think that's one. Aha. So this is what's being executed. We could see right there, home Xkitty app. So we can read that code probably. And home Xkitty app y and better null byte. Okay. So that didn't work like I thought it would. Let's see, home, Xkitty app y. Okay, so let's see. No, that didn't work. Can we read this one? Let's see. There you go. Did that work? Aha. Okay, well, that's not the whole code. So it's interesting. That didn't work. Home, Xkitty. So couldn't read the code entirely, but that's okay. See, probably I made a mistake somewhere. Let's see, app y. Yeah, this looks right. Let's see, can I do it this way? File, embedded null byte. Okay, so that's all right. Let's go back to, just in case I messed it up. Let's see, WD. There we go. So what can we do from here? Well, let's go back to the Werkzeug exploit, which I close. right here. So we need a couple of files, and let's see, what do we need? Here you go. So we're gonna need this. So let's copy the code first. Oh, interesting. Look at that, get machine code. Anyway, let's get this one. And let's focus on the public bits. So let's do pin exploit. So let's do get, let's do pin. Copy it. So the username that is being executed, we have maxkitty, and the app application. Now, this is where it gets tricky. You can easily mess this up. So if you remember the error, so it's tempting to do this one. That won't work. If we create an error, and we saw it before, we should find that this is what we're looking for. Right there. Okay. You only get 10 tries per instance. So if you mess something up, you're gonna mess this up. Like, it's gonna be easy to mess up. So now we need the MAC address and the node and then the machine ID. We also need to confirm this, and I believe that can be easily found. Let's see. So if we look at the machine ID, right there. It also wants this, but we actually don't need it here. Let's see. See, so we need to get the get node print. Okay. So it starts with proc net arp, and we're going to do that here. Let's see. And we have 0 here, and then we need to get this, and there we go. TH0, and we get the MAC address, and now we just need to kind of follow what it does here. So we'll do Python 3 print, I think it's 0x. We gotta remove these. There we go. What does it want? And then address. Oh, okay, yeah, that I think that's the node. So we're going to paste that there. And for the machine ID, let's see, I think it wants this one. There we go. Aha. Now, the exploit will vary per instance, right? Before I run it, if you, and I made this video private up until a day ago, ready set exploit OWASP. If you, let's see, I did a video on this a little while ago. If you go to videos, you will find this video right here, where I kind of walked through it using another one of TryHackMe. I had found this unintended for the room creator, and this is where this idea spawned from after I spoke to the creator about it. And it is almost the exact same steps. The only difference in this one is I believe it uses one more file, which is this one, right? Which we don't need here. And that one uses an MD5. This one uses the SHA-1, which is a newer instance. And we can actually find that out pretty easily if we go here. So let's see. Do that one more. So if we do this, let's cat the pin. Gonna do right here. There we go. If we look for SHA-1, it's using the SHA-1, no MD5, right? So that's another way to figure it out. If we go here and use and look for this file, where is it? Right? See, random boot ID with the first line of prox alpha df to the dash. So there's definitely a lot of files you could use, and if the first method doesn't work, you can keep trying. See, so we have this. So this, I think the other exploit uses that one. But yes, you will need this. Sometimes you might need this as well. In our case, we only need machine ID and this, right? If we run it, get the pin. I think I did it right. Let's see. Hopefully I don't mess it up. Pin. Nope. Let's see, where did I go wrong? Pin. Oh, well, there it is. Max Giddy. There you go. Let's try that again. And we're in the console. So see, little typos can mess you up. And right over here, we have this handy little code. Werkzeug PIN. Cyber Chef. I not spelled that right. So now I'm gonna minimize everything. Getting a reverse shell is trivial. Let's see. Actually, I'm not gonna do it here. Quit. I shouldn't do it here either. Get UUID. There we go. Reb, just in case I mess something up. Let's see. Reb shell 10.13.4.71 9000 bash. Just a custom program I have so that I can just print some basic shells. I could have just used repshell.com, but there we go. And the reason why I want CyberChef is because I want to convert this to base 64. I want to get rid of these pluses. Let's see, not there. Just create an extra space. This one there. There we go. So now the reverse shell is pretty trivial. Just do echo, paste it, pipe base 64-d pipe sh, and before, make sure I'm listening. And we're gonna press enter. Nothing's gonna happen. That's okay. Oh, we have a shell. And now let's upgrade. There we go. Control Z, T put lines, T put calls. STTY raw dash echo FG. Press enter twice. Rows 36. This is so that we have terminal wrapping, and export turn. This is so that we can clear our screen if needed. And we are demxgit user. No interesting groups. Sudo L. Need a password. We don't have it. There's an app directory. We could also get our flag there. There's a git config file. That's interesting. Nothing there. Let's see. Let's go to the app directory. Oh, there's an SSH folder. Let's see. Authorized keys. So nothing there. CD app. This is the source code. And we have an app directory, and there it is. So always good to review the source code to see understand kind of what's happening. Also, there's a password here for MySQL, so you can try that. So there's the route. That's the main page. There it is. Downloads, file ID. So if file ID is not empty, select that. That's, yeah, I mean, I know it helps that I knew the machine, but pretty much what I had. So select URL from else where URL ID equals, yeah, file ID. And this is where the injection happens, see? And then download it. Okay, let's try that password that we found. Let's see, su root. That did not work. Yep, that's it. Let's do sudo-l. Did not work. One thing to notice here is there is a git directory. Git config. Anything there? No? Alright, so let's do git logs. Now we can view a lot of the commit history. And we see initial files, added MySQL utilization, MySQL user. So we are on this last one. Fix image minor update, final changes, change MySQL user. So a good idea is to go down one by one to see what changed. So for example, there's some that will kind of stand out. So we could do git diff to look at the differences. This was deleted, this was added, same here. Okay, that's it. So that was a minor update. How about this one? Git diff, and oh, this was deleted, that was added. Now we don't really need access to the database because we know what's on there from the SQL injection, but that is a different password. Is that root's password? It is not. It's the McSkitty's password. It is, and we can execute this as root for some reason. Can we SSH? Head and map. SSH McSkitty at 10.10.167.30. Yes. Public key signing only. So we could drop a key in this SSH directory to have ease access. Probably should, but should be fine. You know, let's hope nothing happens. So let's review this script. Let's see. You know what? No, it should be fine. I'll just do it. SSH keygen. Oh, that's not it. RSA. So we're going to generate no passphrase id.pub. We're going to add it to authorized keys. Gonna read this. There we go. BI ID RSA. Copy it. Give it the appropriate permissions. Just in case. Good to maintain persistence. There we go. So now we are SSH McSkitty. So again, this could come in handy. Let's just keep this password handy. So sudo-l password. There it is. So what's on there? Actually, let's just read the script. So bin bash. That's odd. You don't typically see this. So it's invoking this bashrc file, and every home directory has it. See? Then it goes into our home directory. So these two lines are the first two odd lines. If you've written some kind of bash script, you would know that this is odd because you don't need this if you read the rest of the script. See, we set a variable. It does a curl command, gets the response code, check the HTTP response code. If it's 200, website's running. Otherwise, it's not. And this is interesting. So it sets it on echo. CD doesn't need it. And curl. So these are the interesting things, right? So you don't need, the script will run even without these, right? The second odd thing, the secure path. It has home McSkitty at the beginning. So if you are unfamiliar with the path, whenever you run an executable, unless it's bash built in, well, no, actually, let me not say that. If you run an executable, it will go through the path, right? So if we look at the path, the standard path, see, it has home McSkitty. So let's say I want to run ls. it would look at home exkd first, right? Before, to see if ls is there. Then if it's not there, it goes to local.bin. Then it goes to user local sbin, then user local bin, all the way until it finds it. And if it doesn't find it, it doesn't run. If we look at which ls, so every time I execute ls, it'll go all the way through here until it finds it here in user bin. And then it'll execute it, right? If ls is here, it will execute there. That's known as path injection, right? I mean path hijacking. And you can essentially drop, if you can drop your own malicious process, it will execute the one you created. However, that would work if, for example, curl didn't have the full path set. If you set the full path, it would go to that one specifically. CD is a bash built-in, which I'll get into in a second. So you cannot really hijack bash built-in unless a specific condition is met. So let's break down the exploit again. Let's run it actually. See what happens. Sudo website's running. Okay, so doesn't do much. Let's look at this. What is the difference between that one and ours? This little line right here that's on this. What's that about? Let's see. What is, probably should do that. And honestly, I should, because the mine is in Google. Well, let's see. What is, so the enable command in Linux is a built-in shell command. It's used to enable and disable the shell built-in commands. So we get a lot of enable built-ins here. We have this page, enable -n, disable the names listed, otherwise names are enabled. It gives us an example. So what are built-in shell commands? Man, let's see, it's a nice page. What are? Let's see, I think it's a good one here. Born shell built-ins. I want to have a list because there's a lot. There's actually, oh, okay, that one has it. So built-in commands, right? Exif, exec, continue, eval, hash, and test expression. Okay, let's see. And let's see, is there, there's a nice page. Aha, there we go. So the Linux man page, so these are all the built-ins: bash, alias, background, and this one right here. So if you're like, what is that? That's an if statement. So if you're used to Python like me, an if statement, or like in C, not Python. In C, you're used to the parentheses, but here is different. This is this is actually a binary and is used in bash to test the if statements, right? And as you see, that exists as a binary here. File, it is an executable. So that should be the very first clue that there's something odd, that it is enabling -n this. So what does the -n do? If we go back to this page, it gives us an example. To use the test binary found via path instead of the built-in. So bash has this built-in where unless you specifically say, you could think of it like enable, no. So don't enable this, right? That means you can use your own bash built-in, right? Otherwise, if you don't specify this, it'll use the bash built-in tests that comes in the system by default. So in this case, maybe user bin. So if we apply it to our case, this enable -n, this is, I commented out. So I commented that out. This means when we load up this script, we're loading this script here, right? We're running this the bashrc profile so that any commands on here go based off this, right? And if we actually look at it, Oops. This is at the very top. This is the first thing it'll run, right? In case it's not running interactively, then it cancels. Everything else is the same. So what it loads this up, it says enable this. Do not enable this. Do not enable the default bash built-in of this. So that means everything else. Then it goes to CD, and then website URL, response, curl, and it gets used here. So because this is saying use the one on the path, right? And right now it looks at user bin because that's where it is. But because we're saying follow the one on the path, and the first place on the path is this, if it exists here, then it will run that one first. And we control this directory right here. We have full write access as McSkitty. We can hijack it, right? And it's easier shown. So let's do bi that bash chmod there, and we're gonna run it, and we're the root user, just like that. It seems very simple, but it's about putting all the pieces together, and it's something, believe it or not, a lot of users don't know. I didn't know about this until not too long ago. So this is, I think, a very sneaky, simple but sneaky path hijacking, right? So that's really what it came down to. Although the execution was not difficult, it's really not difficult at all. It's just knowing what to look for is what made it difficult. And if you have never heard of it, and the thing is, you probably seen it at some point, but you probably didn't fully, you just forgot. It's just not something that we typically would think of. We go to the root directory, and there are flags. The last two Easter eggs are in the frosto directory. There is a note from frosto, and this is where I kind of try to tie it all together. I have a high suspicion the Bandit yet is looking for a way, that's us, infiltrate the best festival company, best festival group. Pretty sure I messed that up now that I realized it. Why are we so one of the questions was, why are we using the database to download images? Can we just download directly from the site? That is pretty much that's true, to kind of add some realism to it, I guess. Otherwise, please make sure the queries are properly sanitized. Yeah. And you don't need root privileges, amongst other things, on the website checker script. This was supposed to be taken care of. Even if we didn't run that as root, we would have never escalated. But that's not the only problem. We don't need those first two lines. Should have put that in there. Detective frosto. And the last, and this ties into that first image we found, the frost links, right? So kind of like this frosto working on the case, right? This is the Frostlink 5 description. So just a little Easter egg, kind of tying the challenge together. So that was pretty much it. I hope you like the challenge. Hope you had fun with, if you attempted it, if you were able to solve it, great. If you didn't, hope you this video finds it helpful, and the write-up as well. So I had a lot of fun building this one, taking that initial idea of the console exploit via SSRF and adding extra layer of SQL injection, and then the privilege escalation. I think is a very elegant exploit, as said by other users. Simple, very easy to miss, but once you see it, it's one of those aha moments. So feel free to comment, like, and subscribe, and see you all next time.